Hello everyone. We now proceed with our discussion concerning random variables and probability distributions. So this is the previous slide I have presented before. So we now move with our next topic. So we have here discrete probability distributions. So I have already introduced probability distributions in my previous discussion. So we now continue. So we have here discrete probability distribution. So it involves all possible values of a discrete random variable and the probability of each value of such random variable that sums up to 1. Now, so I have already introduced last time. So what is a discrete random variable? No? So check that out. No? So for instance, I have this example. In tossing a coin 3 times, let x be the random variable for the number of heads that turns up. Now, so in tossing a coin 3 times, let x be the random variable for the number of heads that turns up. So here's the sample space. So we have 8 outcomes in the sample space. 4, 5, 6, 7, 8. And these are the possible values of the random variable, right? So these are the possible values. So in here, we let x be the random variable for the number of heads that turns up. So in our first outcome, we have 3 heads. Second outcome, we have 2 heads. And then until we reach the last outcome, we have 0 head. Okay? And take note, the probability of each value of such random variable sums up to 1. Okay? So the probability that the random variable is equals to 3 plus the probability that the random variable is equals to 2 plus the probability that the random variable is equals to 1 plus the probability that the random variable is equals to 0 sums up to 1. No? So that is the characteristic of a discrete random variable. A discrete probability distribution. No? Okay. So in this case, note that the probability distribution of such case can be represented by table or probability mass function plot or probability histogram. So there are 3 ways on how to represent the probability distribution. No? It can be by means of a table. No? So, or it can be by means of a mass function plot, probability mass function plot, or probability histogram. No? Okay, so here's the probability distribution table. So as you notice, we have here the random variable and the probability of that random variable equal to a certain value. No? So denoted by f of x. No? F of x. Okay. So f of x is equals to the probability that the random variable x is equal to a certain value x. No? So probability that the random variable x is equal to a certain value x. Okay? So for example, if I have f of 0, so this is the probability that the random variable x is equals to 0. Okay? And the probability that x is equals to 0 is 1 over 8. So how did we get 1 over 8? So we have, if we will take a look at the previous table, we have here 0, value of x. And there's only one outcome out of 8, right? That has a 0 value. No? So in that case, 1 out of 8 is the probability that the random variable x is equals to 0. So this is 1 over 8. Another example, if we consider f of 1 for the value of x equals 1, so this is the probability that the random variable x is equals to 1. And in this case, so this is what? So we have 3 outcomes for 1, right? 3 outcomes for 1. And in that case, 3 out of 8. So this is now the probability. Okay? For x equals 2, 3 as well. 3 out of 8. For x equals 3, we have 1 out of 8. If we add all of these, no, 1 over 8 plus 3 over 8, 4 over 8 plus 3 over 8, 7 over 8 plus 1 over 8, 8 over 8, that is equals to 1, right? So it sums up to 1. Okay? So this is the characteristic of a discrete probability distribution. No? Okay. So this is another way on how to represent the probability distribution, no? By means of a probability mass function plot. No? So in here we have the x and the f of x axis. No? So at the x-axis and the f of x-axis. So for x equals 0, we have 1 over 8. So we plot 0, 1 over 8. So 0, 1 over 8. 1 over 8 is 0.125. No? That's why we have here 1. This is 1 over 8. Okay, 0.125. Okay, and then when x is 1, okay, when x is 1, that is 3 over 8 between 0.335 and 0.4. Okay, so 0.375, right? 0.375, if I'm not mistaken, that is 0.375 between 0.35 and 0.4. So this is 3 over 8. And then we have 2, 3 over 8. Okay, so this is also 3 over 8. And then we have 3. That is 1 over 8. Now we have 1 over 8. So this is the probability mass function plot. Now, and then we can also represent our probability distribution by means of probability histogram. So we have here the same, no? We have the x-axis and the f of x-axis. Okay, so we have x equals 0, x equals 1, x equals 2, and x equals to 3. Okay, and for x equals to 0, we have 0.125. So we just draw a rectangle, then shade. No, we shade. No. For x equals 1, we have f of x equals to 0.375, then we shade. Okay. For x equals 2, same. Then for x equals 3, we have that. Okay. So where f of x equals to probability that x equals to x, no? So this is the probability mass function of the discrete random variable x for a certain value x. Okay. So this is the notation, no? Summation f of x for all values of x is equals to 1. Okay, so in the given example, so f of 0 when x is 0, that is 1 over 8, no? Plus f of 1, that is 3 over 8, plus f of 2, that is 3 over 8. Then f of 3, that is 1 over 8, sums up to 1, no? Okay, so let's now solve problems about this topic. So we have a shipment of 20 similar laptop computers to a retail outlet contains 3 that are defective. If a school makes a random purchase of 2 of these computers, find the probability distribution for the number of defectives. So solution, let x be the random variable for the number of defective laptops. No? So what is being asked in the problem? Probability distribution for the number of defectives. So probability distribution. So if our concern is probability distribution, we have to identify first the random variable. Okay, and then we construct the probability distribution of that random variable. So as stated here, for the number of defectives, probability distribution for the number of defectives. Therefore, this concerns about the random variable, probability distribution of a random variable. So the random variable here is the number of defective laptop computers. No? So that is a random variable now. Let x be equal to random variable for the number of defective laptops. So in that case, we solve for the probability for 0 defective laptops. So how did we get this answer? So before I introduce the solution, so let's analyze carefully the problem. So we have a shipment of 20 similar laptop computers, no, to a retail outlet, contains 3 that are defective, no. So if a school makes a random purchase of 2 of these computers, find the probability distribution for the number of defectives. Okay, so 20 laptops. Okay, and then these 20 laptops, 3 are defective, 3 defective, 17 good. Okay, so a shipment of 20 similar laptop computers to a retail outlet contains 3 that are defective. So if a school makes a random purchase of 2 of these computers, find the probability distribution for the number of defectives. So we have here from 20 laptops, 2 were selected. 2 selected. No? So if a school makes a random purchase of 2 of these computers, so 2 selected by the school. Okay. So what is now the probability distribution for the number of defectives? No? So if 2 were selected by the school, no? 2 were purchased by the school, no? 2 laptop computers were purchased by the school. So what is a probability distribution? Construct the probability distribution for the number of defectives. No? Okay. So first thing to do, we have to determine the random variable. After that, we have to identify all the possible values of that random variable. And then we have to identify also the probability of a random variable equal to a certain value. So, tatlo yung gagawin natin. So, nagawa na natin yung una. Ayun, ano lahat ng possible values ng ating random variable? So, all the possible values of the random variable are what? All the possible values are, kasi ang random variable natin, number of defective laptops. 2 were selected by the school, no? At random. O, kumuha sila ng 20 laptops. Kumuha sila ng 2 laptops from 20 laptop computers. So, sa dalawa na yon, ano yung mga possibility? 0, defective. That's a possibility. Doon sa 2 laptop, posible na walang defective yung makukuha. Because we have 20 laptops all in all. At 17 doon ay good. So, yung 2 na yon, pwedeng good lahat. Ibig sabihin nun, 0 defective yung makukuha. Another possibility, magkaroon ng isang defective na laptop. Right? So, kasi 3 yung defective. So, posible na isa doon ay defective, isa ay hindi. So, sabihin niya, number of defective laptops is 1. Okay? So, in other words, ito yung ating sample space. Okay? So, pwedeng good, then good, defective, okay? Or defective. Okay? Or pwede rin, should I say good? Okay, sorry. So, unang laptop, good. Pangalawa, good. Or good, then defective. Defective, then good. Defective, and defective. Tama? So, lahat ng yan ay yung mga possibilities. Good, defective, good, defective. Kasi dalawa yung sinelect, kaya pwedeng good, defective, good, defective. Yung laptop, di ba? So, dito, value ng x, good, sabihin niyan, 0. Dito ay good, defective, 1 defective. Defective, good, 1 defective. Defective, 2 defectives. Okay? So, 0, 1, and 2. Yun ang lahat ng possible values ng ating random variable. Okay? So, we can proceed. So, we have 3 possible values of our random variable. Okay? So, in this case, so probability that x equals to 0 now is 3c0 now times 17c2 over 20c2 equals to 68 over 95. No? Okay, paano nakuha yan? Ganito lang yan. So let's analyze. So this is f of 0 equal to probability that x equals to 0. Kasi alam na natin yung mga values eh. Alam na natin yung mga values ng all possible values of the random variable. Ang next na gagawin natin ay hanapin natin yung probability na yung random variable na yon ay equal sa specific value ng random variable. So, ibig sabihin niyan, kunin natin yung f of 0, f of 1, and f of 2. So, pag sinabi natin f of 0, that is probability that the random variable x is equal to 0. And that is equals to what? So, ano yung probability na walang defective? Okay, paano nakuha to? So, in here, we have f of 0 equals the probability that the random variable x is equals to 0. And that is equals to 3c0 times 17c2 over 20c2, which is equal to 68 over 95. Now, the question is, how did we arrive at this solution? So, since our goal is to determine the probability that the random variable x is equal to 0, where x is the number of defective laptops. So in here, 0 defective laptops. So if our goal is to determine the probability that we will have zero defective laptops, so we have to consider the number of laptops that are not defective, because we should get 0 defective laptops. No? So therefore, from 3 defective laptops in the population of 20 similar laptop computers, we will we will select nothing. No? We are to select none. No? So we are, therefore, that is 0. So 3c0 multiplied by 17c2. So 17c2 is the number of ways of selecting 2 good laptops from 17 laptops in our population, because all in all there are so there are 17 good laptops while there are 3 defective laptops, no? So with that, this is our solution. We multiply, no, the number of ways of selecting not defective laptop, no, multiplied by 17c2, which is the number of good laptops, no? Good laptop computer, 17 in our population, and we are to select 2 from those 17, no? And then we divide it by 20c2, the total number of laptops in our problem, which is a combination of good laptops and defective laptops, and we are to select 2. So if we are to select 2, some are defective, some are not defective. Okay, so which is equals to 68 over 95. Okay, so this is a topic on probability rules. Okay, so just watch the video related to this topic, no, to better understand it. Okay, so we now move on. So let's now determine the probability that the random variable x is equals to 1. So the probability that there will be one defective laptop when two laptops are selected. No? What is the probability that there will be one defective laptop when 2 laptops are selected from 20 laptops? Okay? So first thing we have to consider now the number of laptop computers that are defective and not defective. So 3 laptops are defective, 17 are not defective. And we are to select 1 laptop that is defective and 1 laptop that is not defective. Okay? because the requirement in the problem is the probability that the random variable x is equals to 1. So one defective laptop. So if I will select two laptops, okay, one should be defective and one should not be defective. Okay, that's why our solution is like this. Okay, 3C1 times 17C1. Okay, take note I use multiplication because recalling probability rules, no, this is not an option. Okay, it's not an option. That's why I use multiplication. Okay, it's a must that there should be one laptop that is defective and another laptop that is good. Okay, a total of two laptop computers to be selected. Okay, and then we divide it by the total number of laptop computers. Okay, combination 2, no? The combination of 20 laptop computers taken 2 at a time. So in here we have 51 over 190. Okay, so that is our answer. Next we have the probability that the random variable x is equals to 2. So in here, similar to the previous two, no? Two probabilities, f of 0 and f of 1. So for f of 2, okay, so we are to consider the number of laptop computers that are defective, which is 3, and that those laptop computers that are good, 17. So 3C2 times 17C0 over 20C2. Okay, we are to select two laptop computers that are defective from 3 laptop computers. Then we are to multiply that by the number of ways of selecting 0, 0 good laptop from 17 good laptop computers. Then divided by 20C2, the number of ways of selecting 2 laptop computers from 20 laptop computers. Okay, so that is equals to 3 over 190. Okay, so we now move. So this will now be the general formula, no? F of x is equals to probability that the random variable x is equals to x. Okay, so which is equals to 3cx times 17c2 minus x over 20c2. Okay, so we had arrived with this solution. Okay, considering the three probabilities, no? So this is x, right? We start with 0 laptop, 0 defective laptop, followed by 1 defective laptop, followed by 2 defective laptops. Okay, so that is represented by x. Then we have 2 here. Okay, we have 2, followed by 1, followed by 0. So 2 good laptops, 1 good laptop, 0 good laptop. Okay, so meaning that will be 2 minus x. 2 minus x, no? That will be the solution now. So if we have 0 good laptop, okay, sorry, 0 defective laptop, so that is, this will become 0, and this will become 2 minus 0, we get 2. If we have 1 defective laptop, so this is 1, 2 minus 1, we get 1. If we have 2 defective laptop computers, okay, so that is 3C2 multiplied by 17C2 minus 2. Okay, so that is 17C0. Okay, over 20C2. And that is equals to 3 over 100, sorry. Hindi na yan. Okay, so this is the general formula, no? Okay, so we now proceed. So this is now the our table, no? So as you notice here, the probability function, the probability mass function f of x is represented by a formula, no? So this is now our formula, no? Okay, so we have here now x and f of x. We construct now the probability distribution table. Constructing the probability distribution table, no? So we have x, and all the possible values of it are 0, 1, and 2. And we consider f of x. We start with 0, we get 68 over 95, okay, here. Followed by 1, we get 51 over 190. Followed by 2, we get 3 over 190. Okay, so that's the solution. No? Alright, so we now proceed. So if we add all of this, 68 over 95, 51 over 190, plus 3 over 190, we'll get 1. Okay? So this is now the probability distribution of our random variable, no? Which is the number of defective laptop computers. Okay, here's the second problem. Determine the value c so that each of the following functions can serve as a probability distribution of the discrete random variable x. Okay, so our objective here is to determine the value of c so that f so that the function k can serve as a probability distribution of the discrete random variable x. Okay, so in this case, how do we solve the problem now? Alright, so let's consider letter A. F of x equals c quantity x squared plus 4 for x equals 0, 1, 2, and 3. Okay, so our solution, recall that summation f of x for all values of x is equals to 1. Okay, so that means that we start with 0 because for x equals 0, 1, 2, and 3. So we start with 0, we have f of 0 plus f of 1 plus f of 2 plus f of 3 gives us 1. Okay? So this is the process so that we can uh, transform the function, no? So that the function can serve as a probability distribution, okay, of the discrete random variable x, no? So in this case, we can now solve for c, considering the problem. So considering the problem, we have c, 0 squared, we substitute 0, 0 squared plus 4, plus c, 1 squared plus 4, plus c, 2 squared plus 4, plus c, 3 squared plus 4. Okay, then that will give us 1. Simplifying, we have 4c, 5c, 8c, 13c equals 1. And that gives us c equals to 1 over 30. So that is now the value of c, which is 1 over 30, so that the function f of x can serve as a probability distribution of the discrete random variable x. Okay, so we can now proceed with letter B. No, for letter B, here's the problem. So as you notice, this is another way on how to represent combination. Okay, so we have this notation. Huwag nyo lalagyan ng over wala yung over. Ganyan lang talaga yan, no? So we have the combination of 2 taken x at a time, then combination of 3 taken 3 minus x at a time. So we have c 2cx times 3c 3 minus x. Okay. So this is the interpretation, no? So this is the interpretation. If I have n and r, that is simply NCR. Okay. And then we have, let's recall, no? So summation f of x equals to 1 for all values of x. So we have f of 0 plus f of 1 plus f of 2 is equals to 1. And then we have now c multiplied by, so as you notice, we have 0, 1, and 2. No? F of 0, f of 1 plus f of 2 gives us 1. This should be equated to 1 so that the function can serve as a probability distribution of the discrete random variable x. Okay? Remember that. And we have here f of 0. F of 0 is c 2c0, 3c 3 minus 0. No? F of 1, we have c 2c1, 3c 3 minus 1. Then f of 2, we have 2c times 2c2 times 3c 3 minus 2. And that gives us 1. And this will now be the simplification. Okay, using calculator, we can arrive at this. And c now is equals to 1 over 10. So the value of c is equals to 1 over 10. Okay, that will such that the function can serve as a probability distribution of the discrete random variable x for letter B. Okay, so we now proceed. So here's our next topic called binomial distributions. So this is a type of discrete probability distribution. Okay, so a binomial distribution is a discrete probability distribution that is obtained by performing binomial experiments. Okay, we have here binomial experiments. So in other words, there are only two outcomes in the experiment. There are only two outcomes. That's why it's called binomial. So binomial experiment, it is a random experiment involving two outcomes. Okay, for each trial. Let's say trial 1 of the experiment, trial 2, trial 3, and so forth, where the sum of the probability of the two outcomes is equal to 1 and remains constant for each trial. So that is the characteristic of this experiment, which is a binomial experiment. It is a random experiment, okay, involving two outcomes for each trial, okay, and the sum of the probability of the two outcomes is equal to 1, okay. So, and upon repeating the experiment, okay, the probability remains constant for each outcome. For each outcome, the probability remains constant. That is the characteristic of a binomial experiment. No? So we proceed. No? So properties of a binomial experiment. So the experiment consists of n identical trials. Okay? N identical trials. So similar trials, no? And similar trials or identical trials. Okay. For each trial, there is a probability of success P for one outcome and probability of failure Q for the other outcome. Okay, for every trial, Okay, there is a probability of success and probability of failure. Okay, so it's either success or failure. Okay, for every outcome, no? So there is a probability of success P for one outcome and probability of failure Q for the other outcome. Okay, so P and Q values remain the same for every trial. So P and Q values remains the same for every trial. So later I'll give you an example to this, no? Okay. So let's say there will be repetition, no? Trial 1, trial 2, trial 3. For every trial, P and Q values remains the same. Where P is what we call as the probability of success and Q is what we call as the probability of failure. Trials are independent, no? So trials are independent. So meaning when a certain event has happened, okay, let's say trial one occurs, okay. Now here comes trial two. So the probability of a certain outcome, no, to occur does not is not affected by the previous trial. That's why it's independent. Okay? That is true for all. Okay? It does not depend on the previous trials. The probability of the occurrence of a certain outcome in that trial. No? So, in this case, again I repeat, trials are independent. The outcome of a certain trial does not affect, okay, the probability of occurrence of the outcome in the next trial. So that's the interpretation. No? The outcome of a certain trial, okay, let's say trial 2, no, does not affect the probability of occurrence of the outcome in the next trial. Let's say trial 3, okay, so that's it. So note that Q is equals to 1 minus P. So Q is equals to 1 minus P, okay, and the probability that a random variable x is equal to a certain value x for a binomial distribution is given by this formula. Now, so we have probability that the random variable x is equals to a certain value x is equals to f of x, which is equals to the combination of n taken x at a time multiplied by the probability of success p raised to the power of x, which is the value of the random variable, multiplied by q, which is which is the probability of failure, no, multiply raised to the power of n minus x. Okay, so again, what is n here? Maximum value of the random variable x. Okay, so n is the maximum value of the random variable x. Okay, where x starts with 0 and ends with n. Okay, x starts with 0. The value of the random variable starts with 0 until reaching n. Okay, now before we proceed to a problem, let me give you an example. Okay, so let's say I toss a coin, tossing a coin. Okay, in tossing a coin twice. Okay, tossing a coin twice. So the sample space has the outcomes head head, head tail, tail head, and tail tail. No? So in here, so if I repeat, if for instance, in every trial, in every trial that is tossing a coin, in every trial tossing a coin. Now, probability that head will appear, that is 1/2, right? And probability that tail will appear, or this is a probability that, okay, head will not appear, no? So, and age, meaning not head, okay? Probability tail, which is probability not head, or this is preferable, age prime, okay? Probability head, 1/2, probability not head, 1/2 as well. So probability head, this is denoted by lowercase letter p. This is probability of success. Okay? Probability of success. On the other hand, we have p of h prime, meaning not getting ahead. Okay? That is equals to 1/2 as well, right? So, dalawang outcome lang naman yan. Diba? In every trial, head or tail lang yan. Okay? So, in every trial, head or tail. So, that means yung tail, not head. Okay? Not getting ahead. So, therefore, 1/2 and 1/2 lang yan. So, this is now denoted by Q. No? P of H prime, not getting ahead, is the probability of failure denoted by Q. Because your probability of success is denoted by P, which is 1/2. Okay? So, yun ang ibig sabihin ng P and X. No? P and Q, I mean. No? Yan ang ibig sabihin ng P and Q. No? Okay, so apply natin yung topic na to sa isang exam, sa mga examples natin. So, problem solving on binomial distributions. So, find the probability that in tossing a fair coin 3 times, there will appear 2 heads and 1 tail, and 2 tails and 1 head. Okay. So, we have here tossing a coin 3 times, no? So, if we are to toss a coin 3 times, so we are to determine the probability that there will appear 2 heads and 1 tail, and 2 tails and 1 head. Okay, let's analyze the problem. So we have n is equals to 3. Okay. So number of trials, 3. Find the probability that in tossing a fair coin 3 times, number of trials is 3. Okay. Now, find the probability that in tossing a fair coin 3 times, there will appear 2 heads and 1 tail. So here's 2 heads and 1 tail. Now, solution to the problem, we let x be the random variable for the number of heads in 3 tosses of a coin. Okay? X is the random variable for the number of heads in 3 tosses of a coin. No? So, random variable for the number of heads that turns up in 3 tosses of a coin. So, in every trial, okay, tossing a coin, in every trial, P is 1/2. Head or tail lang yan, right? Probability of success and probability of failure. No? So dahil ang ating random variable concerns about number of heads, therefore, In every trial, we consider the probability na makakakuha tayo ng head. So, ibig sabihin nito, ito yung probability na makakakuha tayo ng head sa isang trial. So, sa isang trial, ano yung probability na makakakuha ka ng head? 1/2. And on the other hand, the probability that you will not get ahead is 1 minus p. This is the probability of not getting ahead, 1 minus p. Okay? Which is equals to 1/2 because p plus q is 1. Yan ang characteristic ng dalawang probabilities. Probability of success plus probability of failure is equals to 1. Okay? So, yan ang characteristic. And then, so here's the formula for binomial distribution. So, the probability that the random variable x is equals to x is equals to f of x is equals to the combination of n taken x at a time multiplied by the probability of success p raised to the power of x multiplied by the probability of failure q raised to the power of n minus x, for x equals to 0, 1, 2, and so forth until we reach n. So, let's continue. This is our concern, 2 heads and 1 tail, and we had let x be the random variable for the number of heads in 3 tosses of a fair coin. And this is the formula for the binomial distribution, Okay, so our concern is the probability that there will be 2 heads and 1 tail. So what is if our concern is 2 heads and 1 tail, and we let x be the random variable for the number of heads, therefore, x is equals to 2, right? Because there will appear 2 heads and 1 tail, therefore, x is equals to 2. That's why x is equals to 2 here, which is equals to f of 2. Okay? Which is equals to f of 2. That is now equal to the combination of 3 taken 2 at a time. Okay? Multiplied by 1/2 squared multiplied by 1/2 raised to 3 minus 2. Okay? Remember, 3 times, no, that the coin is tossed. No? So n is 3. So we'll get an answer of, so this is 3c2 times 1/2 squared times 1/2 to the first power. We get 3 over 8. Okay? So checking, here's the checking. You may list all the possible outcomes. Head, 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 tail, head, and so forth. And then the random variable value for every outcome. So we have 3 heads, 2 heads, and so forth. No? So the probability of obtaining 2 heads and 1 tail, that is equals to the probability that the random variable x is equals to 2. Right? Because we let x be the random variable for the number of heads. That's why this is x equals to 2 for in 3 tosses of a fair coin. And that is f of 2. And how many outcomes do we have for x is equals to 2? We have 1, 2, and 3. We have 3 outcomes, right? 3 out of 8. No? 3 out of 8. So that is our answer. So this is an alternative solution. Okay? This is an alternative solution. Okay? So that's it. So we can proceed. So for letter B, 2 tails and 1 head. So we let y equals to the random variable for the number of tails in 3 tosses of a pair coin. Okay? So, and then So, napalitan lang ng y yung x. Imbis na x equals x, y equals y. So, ito pa rin yung binomial distribution. Ito pa rin yung formula for binomial distribution. Okay, so we have f of y equals to combination of n taken y at a time times p raised to the power of y times q to the power of n minus y, where y equals 0, 1, 2 until we reach n. No? So this is now the solution. So we substitute 2, okay, and 3, we substitute 3 and 2. Okay, then we have 3c2 1 half squared 1 half. We also get 3 over 8. Okay, so we can check our solution. Okay, we can check our solution by constructing the table. In my previous slide, I have shown you can do that. No, you can check the solution, and you will arrive with this answer as also 3 over 8. No, okay, try it. No, so number 2, find the probability that in 4 tosses of a fair die, the number 2 appears once and twice. So we have here tossing a die. Okay. Now in tossing a die, we can let y equals the random variable for the number of appearances of number 2 in 4 tosses of a fair die. Okay. So we have a die, right? And we let y be the random variable for the number of 2 in 4 for the number of appearances of 2 of number 2 in 4 tosses of a fair die. Okay. Find the probability that in 4 tosses of a fair die, the number 2 appears once. So what's the answer here for letter A? So here's the probability binomial distribution formula. Okay, formula for binomial distribution. So sabi niya, appears once. Okay, 4 tosses. So number of identify nga natin kung binomial distribution talaga yan. No? Check natin. In every trial, let's say tossing a die, trial 1. Tossing a die, probability na number 2 yung lalabas. Okay, ano yung probability na number 2 yung lalabas? That is 1 out of 6. Diba? Ano yung probability na hindi number 2? Not number 2. So, pag hindi number 2 yung lalabas, ibig sabihin, di ba yung die meron siyang 6 na outcomes? 1, 2, 3, 4, 5, 6. Okay, so therefore, 5 out of 6 yun. So, probability of success, 1 over 6. Probability of failure, 5 over 6. Considering every trial. This is true in every trial. Totoo din yan sa trial 2, totoo din yan sa trial 3, and so forth. Trial 4. Okay? So, inulit yung experiment, inulit ng 4 na beses, no? So, nagkaroon ng 4 trials dun sa experiment. So, in that case, n is equals to 4, no? N is equals to 4. So, we have now f of 1 equals to 4c1. 4c1 yan, okay? Times 1 over 6, okay? Which is p raised to 1. Okay, 1 ay, bakit ito 1? Kasi meron tayong given na appears once. Appears once lang eh. Okay? So, sa 4 tosses, ano yung probability na yung number 2 mag-a-appear lang siya ng isang beses? So, 4c1. Okay? And then, 1 over 6, ito yung P natin, raised to 1. 5 over 6 raised to 4 minus 1. So that's it, no? And we will obtain an answer of 125 over 324. Okay, letter B. The number 2 appears twice. Appears twice naman. So we have y is equals to 2. That is f of 2 now. Probability that the random variable y is equals to 2. Okay? So we have now 4C2. Okay? Kasi meron tayong random variable na value na 2. Kasi the number 2 appears twice. So, kaya 2 yung y na yan. Okay? And then, 1 over 6 in every trial. Ito yung probability na lilitaw ay number 2. 1 over 6. Probability na lilitaw ay hindi number 2. 5 over 6. Okay? And then, we will arrive with an answer of 25 over 216. Okay, number 3. So 80% of the graduates of a certain university who apply to a particular medical school are admitted. This year, 4 graduates from the said university have applied for admission to the medical school. Find the probability that only 2 of them will be accepted. Okay. So let X be the random variable for the number of graduates to be accepted in a medical school. Okay? Now, here's the solution. So we have the formula for binomial distribution. Okay? And let's analyze whether it is really binomial distribution. Is the random variable binomially distributed? Okay? So let's see. So we have 80% of the graduates of the certain university who apply to a particular medical school are admitted. So that is the given. We have 80% of graduates, okay, who apply of a certain university who apply to a particular medical school are admitted. So 80% graduates admitted, okay, in a medical school. This year, 4 graduates from the said university have applied for admission. So this year, 4 graduates from the said university have applied for admission to the medical school. So we have 4 graduates applied, no? Okay, have applied for admission to the medical school. Find the probability that only 2 of them will be accepted. Ano daw yung probability na dalawa lang dito sa graduates na to yung matatanggap? So, tingnan muna natin whether binomial distribution. Tingnan natin Let's say 1 graduate. Kasi kumbaga, ang experiment, meron kang 4 trials, by the way. Yung 4 graduates, ibig sabihin yan, 4 trials. Pag isang graduate, ibig sabihin yan, 1 trial. Okay? So, 1 graduate, 1 trial. Sa isang graduate, ano yung probability na ma-admit? Probability of success. Ano yung probability na hindi ma-admit? Probability of failure. Okay, so we have 80% of graduates daw na nag-a-apply sa isang medical school are admitted. So therefore, 0.80. So in every graduate, 0.80 yung probability. Okay? 0.80 yung probability na matatanggap yung graduate na yon para ma-admit siya sa isang medical school. At yung hindi siya ma-admit, 1 minus P. So ano ang 1 minus P? 0.20. 1 minus 0.80, 0.20. So 20% yung chance na hindi siya matatanggap. 80% yung chance na matatanggap siya kada graduate. Ngayon, kung merong 4 na graduates, ano daw ang tsansa na 2 lang dito yung matatanggap? Kung kada graduate, ang tsansa na matatanggap ay 0.80. So, yun ang ating concern, no? So, let's answer the problem now. So, here's the solution. So, x is equals to 2. No? Kasi sabi dito, only 2 of them will be admitted. Find the probability that only 2 of them will be admitted. So, x equals to 2. And that is f of 2. So, we have the combination of 4 graduates taken 2 graduates at a time. Multiplied by 0.80. Probability of success. Okay. Probability na for every graduate matatanggap siya sa medical school. Squared mo natin yon. Kasi raised to the power of x. Tapos, probability of failure, 0.20. Raised to the power of 4 minus 2. Okay, n is 4, right? Kasi 4 graduates. So, 4 minus 2. 2 yung x. Okay? 2 yung x natin, yung value ng random variable. So, ano yung magiging sagot natin? 96/525. Okay, number 4. Find the probability that in a family of 3 children, there will be no boy, letter B, at least 1 boy, letter C, at least 1 boy and 1 girl. Okay, let's analyze. So we have a family of 3 children. Ano daw yung probability that there will be no boy? Okay, so B is 0. Kung yung random variable natin ay B. A random variable natin ay B representing number of boys. So 0 boy. Okay? At least 1 boy, letter B, and C at least 1 boy and 1 girl. Okay. Analyze natin. Family of 3 children. Okay. Binomial distribution ba to? Binomial random variable ba to? Yung ating yung random variable sa problem? Binomial ba siya? Let's identify. So, 3 children. So, we consider only 1 child. So, sabihin niyan, 3 children, 3 trials. Okay? Kumbaga, 3 trials sa isang experiment. 1 child, okay, ibig sabihin niyan, 1 for every trial. For every trial. Oh, okay. 1 child. So, ang child na yan, it's either boy or girl. Could be boy or girl. No? Now, wala nang iba, boy or girl lang, no? Okay. So find the probability that in a family of 3 children, there will be a no boy. So child, no? It's either boy or girl. Okay? So this is your random variable now. Okay? So your random variable can okay, you can denote that by B, the number of boys. Okay? The number of boys. So, itong girl na to, not boy. No? Not boy. Okay? So, in that case, there will be no boy. So, B is 0. So, your random variable is what? What is a random variable? number of boys. Okay? Number of boys is a random variable. And what is the probability of success? Kung ang random variable mo ay B is a random variable. B, random variable for number of boys. Number of boys. So kung ang random variable mo ay B, ano naman yung probability of success? Related to the random variable for number of boys. Ano yung for every child? Ano yung probability na boy? 1/2. For every child, ano yung probability na hindi siya boy? 1/2. So that's it. Meron ka ng P, meron ka ng Q. Okay? So B is the random variable for the number of boys in a family of 3 children. So this is now the solution. Okay? Applying the formula for binomial distribution. So we have B equals 0. Okay, no boy kasi, kaya f of 0 equals 3. Combination of 3 taken 0 at a time. Okay. For 3 boys, itong n pala, ito yung maximum number ng mga na pwedeng maging boys dun sa 3 children. Di 3, di ba? So itong 3 children, pwedeng lahat boys, right? So therefore, n is equals to 3. Okay? So P, probability that B is equals to 0 equals to f of 0 equals to combination of 3 taken 0 at a time. Multiplied by 0.5 kasi 1/2. Okay, so this is 0.5 or 1/2. Okay, and also ito rin ay 0.5. Okay, raised to 0. Okay, ito yon, tapos 0.5, 3 minus 0, no? N minus B. So that's it, no? So we can proceed, no? So probability that there will be no boy is now equal to 1/8. So yun ang sagot. Letter B, probability at least one boy. Pag sinabing at least one boy, one or more. Okay? So one or more. So kung ganon, ito yung solution. At least one boy. So probability that B is equals to 1 hanggang matapos ka sa probability that B is equals to 3. Kasi meron kang 3 children. At ang possibility ay lahat ng yon ay pwedeng maging boys. So in this case, this is the combination of 3 taken 1 at a time. Multiplied by 0.5 raised to the power of 1 times 0.5 to the power of 3 minus 1. Plus the combination of 3 taken 2 at a time. Multiplied by 0.5 squared times 0.5 to the power of 3 minus 2. Plus the combination of 3 taken 3 at a time. Multiplied by 0.5 cubed times 0.5 raised to 3 minus 3. Okay? So in-apply lang natin yung formula. So we can proceed, no? So ang sagot ay 7/8. Okay, letter C. At least one boy and one girl. Pag sinabing at least one boy and one girl, so sa 3 children na yon, pwedeng one boy and 2 girls or 2 boys and 1 girl. Okay, hindi pwedeng 3 boys and 0 girl. Dapat magkaroon daw ng at least one boy and one girl. So hanggang dyan lang siya. So at least one boy and one girl. Hindi pwedeng 0 boy and 3 girls, no? So 1 boy and 2 girls or 2 boys and 1 girl. Okay, kasi meron kang 3 children. So in that case, at least one boy and 2 girls, at least one boy and one girl, So we have now probability 1 boy and 2 girls. So probability that B is equals to 1. Probability 2 boys and 1 girl. So that is 2 boys. So probability that B is equals to 2. Okay? So ang sagot ay, so we applied the formula. Ang sagot ay 3 over 4. So 75% ang chance na there will be at least 1 boy and 1 girl. Okay? So that's it. No? So number 5, the probability that an entering college student will graduate is 0.6. Determine the probability that out of 4 students, all will graduate. No? Okay, let's analyze. No? So we let x be the random variable for the number of graduates in college. No? So we have the probability that x equals to f of x equals to n, the combination of n taken x at a time, times p to the power of x times q to the power of n minus x, for x equals 0, 1, 2, and so forth until we reach n. Now here's a solution. No? So if we analyze the problem, the probability that an entering college student will graduate is 0.6. So for every student, no? So the probability that he or she will graduate is 0.6. Okay? So this is now your probability of success. Okay? The probability that an entering college student will graduate is 0.6. So 60% ang chance na yung nag-enter ng college na estudyante ay mag-graduate sa college. No? So 60%. So Q naman is the probability that the college student will not graduate. So that is 1 minus P. That is 0.4. No? That is the probability of failure. 0.4. That is for every student. No? That is for every student. Okay? Determine the probability that out of 4 students, all will graduate. So kung meron kang 4 na estudyante, ano yung probability na lahat sila mag-graduate? No? So your random variable is x, and that concerns about number of graduates in college. So P, probability that x equals to 4, that is f of 4. So n is equals to 4 kasi possible na lahat ng 4 na yun ay mag-graduate. Okay? And yung x na to ay 4 dahil yun ang hinahanap. Diba? Ang x natin ay 4. Determine the probability that out of 4 students, all will graduate. So there's the word na all, kaya 4 itong x. Okay? Dahil dito sa 4 students, okay, yung 4 students na yan, may potential lahat na mag-graduate. Kaya n equals to 4. Okay? And then, for every student, ito ang chance niya mag-graduate, 0.6. For every student, ito yung chance niyang hindi mag-graduate, 0.4. So that's it. No? So we can now proceed. So the answer is 81 over 625. Okay, number 6. A lot of 100 batteries is known to contain 10 defective batteries. 5 batteries are selected at random and each battery is replaced before the next battery is selected. What is the probability of getting at most 2 defective batteries? Okay, so let's analyze the problem. So we let x be the random variable for the number of defective batteries. No? So we let x be the random variable for the number of defective batteries. Okay, so there are 100 batteries. Okay, in a lot. So 100 batteries, and is known to contain 10 defective batteries. So 10 defective batteries. Okay, is known to contain 10 defective batteries. So 5 batteries are selected at random and each battery is replaced before the next battery is selected. Okay? So there is replacement done, right? So therefore, na-maintain yung probability na magsiselect tayo ng isang battery. Na-maintain kasi nire-replace no? So therefore, kung na-maintain, uh, pwedeng ma-apply yung, pwede siyang maging binomial random variable yung ating number of defective batteries. Pwede siya maging binomial random variable. Pero meron munang meron pang i-consider na factor para maging binomial random variable. Tignan natin kung for every trial or for every battery na maintain yung probability of success and probability of failure. Let's say, kumuha ko ng battery or kada battery, for every battery, one battery, ano yung probability na defective siya? So, sabihin niya, probability of success ko ay yung probability na defective yung isang battery. Okay? Kasi ang random variable ko ay number of defective batteries. Therefore, yung probability of success ko dapat may kinalaman sa defective battery. No? So, for every battery, ano yung probability na defective? So, ilan lahat ng battery na defective dun sa 100? 10. Ilan lahat ng battery? 100. So, applying classical probability rule, di ba? So, 10 over 100, 0.10. No? Okay? Di ba? Ito yung classical probability rule, n over n. Ito yung sa sample space. Ito yung para sa event. Di ba? Ito yung para sa event, number of defective batteries. So, kaya ito ay 10 over 100. Okay? So, we proceed. So, probability of failure, kung 0.10 yan, 0.90. Yung probability na hindi defective yung battery. Okay? So, therefore, na-maintain yung P and Q. Kasi, we consider every battery. At saka sabi sa problem, it is replaced. Nung nag-select sila ng battery, each battery is replaced before the next battery is selected according to the statement. Okay? So, we can proceed. So, here's the equation for binomial distribution. Okay, we have 5 batteries. We are to consider 5 batteries. Okay, ito yung sinabi ko kanina, 10 over 100. 0.10, so 0.9 yung Q. What is the probability of getting at most 2 defective batteries? Sabihin yung ating random variable x less than or equal to 2. Pag sinabi kasing at most 2, sabihin yan, maximum yung 2 or pwedeng mababa pa sa 2. No? So, yun ang interpretation. So, ibig sabihin yan, probability that x equals to 2 plus probability that x equals to 1 plus probability that x is equals to 0. Okay? So, for x equals to 2, okay, ito yung ating solution. Okay, combination of 5 taken 2 at a time times 0.1 squared times 0.9 raised to 5 minus 2 plus the combination of 5 taken 1 at a time times 0.1 times 0.9 raised to 4 plus combination of 5 taken 0 at a time times 0.1 to the 0 times 0.9 to the 5. Okay? So, what is our answer now? Our answer is 0.9914. Okay? So, that is the answer. The probability of getting at most 2 defective batteries, 0.9914. Alright, so we can proceed. Okay, number 7. So June is taking a multiple choice examination that consists of 5 questions. Each question has 4 possible answers. June guesses at every answer. So what is the probability that he passes the exam if he needs at least 3 correct answers to pass? So here's the solution. Okay, let x be the random variable for the number of correct answers, considering 5 questions, where each question has 4 possible answers. Okay, so let's analyze. Each question has 4 possible answers. Okay, so in this case, if each question has 4 possible answers, and it is being asked, what is the probability that he passes the exam if he needs at least 3 correct answers to pass? So with that, we let x be the random variable for the number of correct answers, considering 5 questions, where each question has 4 possible answers. Okay? So in this case, if we analyze every question, in every question that has 4 possible answers, what's the probability that there will be what's the probability that in that question we get the correct answer? Okay, so what's the probability? So that is 1/4. Okay, 1 out of 4 is the chance that, okay, uh the correct answer will be obtained. How about the probability that June will not get the answer in every question? That's 3/4, right? That is 3/4, 0.75 in every question. Okay, 0.25 in every question that June will get the correct answer. So the question here is, what is the probability that he passes the exam? So meaning he should have 3 or more answers, 3 or more correct answers, okay, to pass the exam. No, so there are 5 questions. So in that case, so we consider n equals to 5. The maximum number, okay, of correct answers is 5, right? Kasi at least 3 correct answers. So therefore, n is equals to 5, the maximum number of correct answers. Okay, in every question. Diba? In every question, okay, so we have, kumbaga, meron kang 5 trials. Diba? Kasi in every question, that is considered trial. Kung meron kang 5 questions, meron kang 5 trials. Okay? At dun sa 5 trials na yon, okay, possible na correct lahat, syempre, no? So P is 1/4, no? P is equals to 1/4. Q is equals to 3/4, no? And ito yun. What is the probability that he passes the exam if he needs at least 3 correct answers to pass? So probability that the random variable x is greater than or equal to 3. Setting solution, probability that x equals to 3 plus probability that x is equals to 4 plus probability that x equals to 5. And we will get, so we have this solution, okay, applying the formula. The answer is 53/512 or 0.1035, no? 0.1035. All right. So I hope you get it now, and that ends my discussion today.